we're going to be taking exponents and raising them to exponents, and I'm going to show you the rule and why it's true. So let's go ahead and take a look at the first example and just follow along. So we have 2 cubed to the 4th power. Another way to read this is 2 to the 3rd power raised to the 4th power. So I'm going to break it down for you. First of all, let's just do the 2 cubed part. If we do 2 cubed, that would be 2 times 2 times 2, okay? We're not going to do anything with that yet. We're just going to write it like that, okay? But we're going to do that 4 times, okay? And for this first example, I'm breaking it down. We don't always have to do it this way. I'm just proving a rule, okay? So we're going to do that 4 times. There's 3. See if I can fit it on one screen. Okay, so there's 1, 2, 3, 4 times. So we've taken 2 to the 3rd and we've multiplied it by itself 4 times, following the rules of exponents. And exponent says multiply something that many times. That's exactly what we've done. Now, listen, so all I want you to do is count how many 2's we have now that are multiplying each other. Okay, we don't really have to multiply them all out, but how many 2's do we have total? Good. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Again, we don't have to work that one out. I know 2 to the 10th is 1024, so 2 to the 11th is like 2048. So 2 to the 12th would be twice of that, which would be like 4096. But here's what I want you to what I want you to focus on is this number right here, okay? Notice that if you take 3 and you multiply 4, you get that number, okay? And it makes sense because we had 3 2's here.
Are you a wizard?
And we did it 4 times. You could do 2 cubed, which is 8, and then raise it to the 4th power. What I'm trying to teach you is a rule in general, which is to multiply those exponents, okay? It's easier that way. Any other questions?
No.
Let's look at another one. I'll show you why this rule is true. 3 to the 4th would be 3 times 3 times 3 times 3, right? And if we do that twice, it would look like this. Okay, and we do it twice because it's raised to the 2nd power. So again, I'll ask you, how many total 3's do we have now? Okay, so you're starting to see that all you have to do is multiply those exponents. Explain. Anyway, we won't be solving this one out, okay, because it's too big. I don't know what that number is. I'm not going to expect you to do anything like that unless you had a calculator. But 3 times itself 8 times would be a pretty big number. But again, the point I want to make is it makes sense that you would multiply those exponents to get to this 8, since we have 4 3's here and we're doing it twice. Okay? In general, if you had an x, yes, exactly. I'll break this one down again for you. It'd be x times x times x times x, since we're raising it to the 4th power to begin with. And then we're going to be doing that twice. So we're going to be multiplying that by itself. So if you count the x's, we have 8 of them, and you can start to see that we don't have to break it down every time. We can just multiply the exponents. So that's different, guys, than multiplying like bases, and that's where you might, for example, what he said, be tempted to write that as 3 to the 6th power. Well, that's a different rule entirely, okay? And I will explain the difference, okay? The name of this lesson is exponents to exponents, okay? Another way to say it is a power to a power, okay? Power is the same word as exponent. So notice that we have a power here raised to a power. Now the difference between the two rules is if I had 3 to the 4th times 3 squared, okay, that is not a power raised to a power. We are multiplying like bases, okay? you can distinguish the difference. Here we have a power to a power, and here we're multiplying like bases. Okay, again, I understand that you can confuse the rules, but I'm explaining to you right now the difference between the two. In that case, you do add them. We already explained why, because you have 4 3s here, and you have 2 3s here, so that ends at 6 3s total. Okay, that breaks down differently simply because it's a power to a power. Okay, so there's the difference between the two rules. Make sure you can distinguish the difference between the two just by the way they look. All right, so again, yeah, so now you're starting to see that you don't have to break it down every time. Step one, when you're simplifying these, is to go ahead and multiply the exponents. So that will give you 15. Now, for this one, I'm not going to make you solve it out. It's too big. So, but for step two, simplify if necessary. If somebody wants to use their calculator real quick, I'll let you type that in and you can tell me what 2 to the 15 is. Yes. Thank you. You said 3, 2, 7, 6, 8. Okay. What was your question?
Our assignment for this, if we have one, probably do you want us to simplify all of them?
Yeah, because on the assignment, you won't get a 2 to the 15th. I think the biggest you might get is like 2 to the 9th or something, which is less than 1,000. So you just double it every time. But yeah, on the assignment for sure, you want to simplify. And it's gonna.
Can you use a calculator on the assignment?
Yeah, you can. All right. So this one can be pretty easy. Again, when you have a power to a power, right, make sure that you multiply them. Do not add them. Okay. So step one, multiply the exponents. Simplify if necessary. Obviously, it's not going to be necessary this time because it's already simple as it gets. Okay. So what we're trying to do is just get that concept solidified as far as what you do with the exponents. So the answer for this one, anybody want to raise their hand? Yes, sir. And that's right. So we're just doing 4 times 20, which gives you 80. And again, that's already simplified. It can't be simplified anymore. Okay, now, as hard as this one is, it's not hard at all. Let's take a look at the exponents. Hold on a second. So what are the exponents here? 4 and 1/2. What's 4 times 1/2?
2.
Okay, so we're going to have 3 over 10. Just because if you think about it, this is a fraction. So if I just had the 4 there without the parentheses around 3 over 10, you might think it's just 3 to the 4th and not 3 over 10 to the 4th. So it's the whole fraction to the 4th. But the point again is that you're just multiplying those two exponents, which gives you 2. And yesterday we looked at how to apply an exponent to a fraction, which is to do what? Okay, so how would you do that? Okay, so basically you're applying that to each part of the fraction. So what's 3 squared over 10 squared? 9 over 100. So that's okay. One point I want to make here is it would be a lot harder to raise that to the 4th and then to the half. You see what I'm saying? It's a lot easier if you go ahead and multiply the exponents. So is that what you were going to say?
Well, what I did before I was trying to figure it out, I did like 3/10 times 3/10. So is that?
Oh, that's the same, yeah. That's the same thing, yep. It should give you 9 over 100. Because when you square something, you multiply by itself. So you're right, that's the same as 3 over 10 times 3 over 10. Okay, again, this one's not hard. It's actually a lot easier than it looks. Yeah, all you got to do is multiply the 5 and the 6. Oh, the way to read this is n over q to the 5th power raised to the 6th power. 5 times 6 is 30. And when you distribute something, when you raise a fraction to an exponent, unless it's actually going to end up simplifying the problem, you don't have to distribute it. Okay, I realize that you could say n to the 30 over q to the 30, but I would say that this is more simple than that, so you can just leave it that way. So this problem only really has one step. Okay, do another one here. 12 to the m to the n power. Anybody want to raise their hand and share the answer? Gets the same rule. That's right. So we're multiplying the exponents, which is m times n. So the answer is 12 to the mn. That's it. Again, notice it's not m plus n, it's m times n. When you have an exponent to an exponent, you multiply them together. And that's already simplified for step 2, so that's going to be the answer. Okay, 2 more. We have a to the x to the 2. Now be careful, because if I were just trying to do this real quick, I would say a to the x squared. But why is that wrong? Right, so again, exponent to exponent is multiplication. So what's x times 2? 2x, right? So as long as you understand its multiplication, you wouldn't be falling into that trap. So that's the answer for this one. We have x to the y to the y. So we're going to be multiplying, well, we're going to be multiplying y times y, because it's exponent to an exponent.
No, why?
Y squared.
Y squared, because 1 plus 1 is 2.
Good. All right, let me break it down for those of
So
you.
then the y would have it.
Because it's got.
You need to listen and you'll understand, okay? It's y times y, right? Like she said, they both have an exponent of 1. That becomes y squared. So the exponent itself is y squared.
The exponent has another exponent.
Yeah. That's not a typical question you're going to get, but just for the sake of understanding the lesson, it's important to understand that, yes, you do multiply the exponents, and y times y is y squared.